Stats 2023, Chapter 9, Section 1, dealing with correlation. Alright. First of all, correlation was defined by it's a relationship between two variables, in this case x and y, where x is the independent variable, or explanatory variable, y is the dependent or response variable. Correlation is a value between -1 and 1 with 0 in the middle. If the r or correlation value has a 0 value, then there is no correlation. The closer r is to -1, the stronger negative association we have between x and y. The closer r is to a +1, the stronger positive association we have. If we look here, here's some examples. We can determine these sometimes with scatter plots. If you look at this scatter plot here, this is showing a negative linear relationship because it's a straight line and going down from left to right. This is a positive linear correlation because it's going up from left to right, straight line. This is no correlation because there is no pattern. And this is a non-linear correlation. It's actually quadratic. We can figure this out, and here I'm doing try it yourself on page 472. What the problem says is the researcher conducts a study to determine whether there is a linear relationship between a person's height and the pulse rate that they have. So if you look at the columns here, x is the first row, y is the second row. Just like in math, x would be the first column, y would be the second column. So what we're going to do is we're going to take this information and we're going to plug it into our list, which I have already done. List 1 has my heights. List 2 has my heartbeats. Then what we're going to do is we're going to second quit out of there. And then we're going to go second y equals, so we get our stat plot. I'm going to go to our first stat plot, make sure that the cursor is on, make sure it's at scatter plot, which is the first icon here. Then what's going to happen is, remember, in order to do a stat, we got to hit zoom, and we got to hit a number 9. The reason we got to hit a number 9 is because number 9 is zoom stats. So I'm going to hit this 9, and there's our scatter plot for that data. And I hope you can see from that scatter plot that the correlation value, the R value is 0 because there is no real pattern. The formula for figuring out correlation is pretty difficult, pretty complex. I'm here to tell you won't have to worry about that. In section 2, we do linear regression, and linear regression actually gives us the R and R squared value for us. There are some other examples. Just by looking at this scatter plot, there's an R value of 1, positive 1. There's an R value of 0.81. There's an R value of 0.45. Here's an R value of -1, R value of -0.92, and then an R value of 0.04. One of the things you have to learn to do is to use table 11 in the back of your book in Appendix B. And basically what happens is really pretty simple. You're going to use two values. You're going to use the sample size, which in this case is 25. You're going to use the R, which is 0.979. And you have the alpha 0.05. So what happens is when you go to this table, you're going to see three columns. A column for N, which is the sample size. A column for alpha, which is 0.05. And a column for alpha, which is 0.01. You're going to be given one of these two alphas, not both. In this problem, we're given a sample size of 25. An alpha of 0.05. So if I come down 0.05 to where it's 25, I get 0.396. Anytime my R is larger than the value I get from the table, then the correlation is significant. And that's exactly what this says. There's enough evidence at the 5% level of significance to conclude that there is significant linear correlation between their durational phase eruptions and the time between eruptions, which is what this data was about. Working another problem, here, it says example 4, you use 10 pairs of data to find R is approximately 0.874. Remember the wavy lines mean approximately. We're using alpha 0.05. So again, we're going to come here. We've got 10. We've got 0.05, so we get a value from the table of 0.632, which is right here. And we can see that R in this problem is larger than the p-value. So as a consequence, there is significance with the correlation between these two values. That's really all there is to it.